Hello, my name is Ling Wan from KAIST. I'd like to present our work for learning event-based and tasks via cross-modal knowledge distillation. Event cameras are novel sensors that sense intense changes at each pixel and produce event streams encoding time, pixel location, and polarity of intense changes, which are different from the frame-based cameras. Event-based and task learning aims to learn end tasks such as semantic segmentation from the event data. To learn the end tasks, some works made pseudo-labels from APS frames and use them for learning DNNs from events. However, labels are less precise because APS frames are of low quality. Meanwhile, some works first reconstruct intensity images from events and then use them for end task learning, such as object classification. However, inference latency is induced and sequentially learning to tasks is less optimal. Some works explored unsupervised learning, but they are only possible for pixel-wise prediction tasks, such as depth estimation. So importantly, compared with the existing frame-based datasets, event-based datasets are less quantitative and qualitative. To this end, our motivation is that as there exists a large number of high-quality labeled datasets, image datasets such as semantic segmentation, we aim to bridge the unpaired and unlabeled event data with the labeled image data first, and then aim to learn an event-based tasks. We propose a method called IfDistill to distill knowledge from teacher network trained with labeled source image data and to learn an event student network on the unpaired target event data. Our framework consists of two modules. The first module is called the bidirectional modality reconstruction module. When APS frames are available, we use APS frames as supervision for image generation and further adapt the generated intensity images to the source modality data to reduce domain gap. Meanwhile, the source modality data is used to generate events as way of data augmentation. To retain the semantic consistency, we propose a semantic consistency loss to recover better texture details for the generated images. The second module is called distribution adaptation module. We first match the pixel-wise prediction information between the teacher network and student networks. And moreover, to match the class information, we propose a distribution matching loss, which is built on conditional adversarial learning. As the features of both modalities contain informative structural knowledge, we then propose an affinity graph distillation loss to match the feature level information. We conduct experiments on 3 datasets for semantic segmentation. On the general scenes of DDD17 dataset, our method achieves comparable performance with APS frames. Compared with previous works, our method achieved the state-of-the-art performance even without using pseudo-labels. Similarly, on the MVXS dataset, our method also shows promising results on events. And in some conditions, the events even show better semantic segmentation performance than the APS frames. To evaluate our method, we follow IfSegNet and make pseudo-labels, and the results show that our method improves the baseline of around 5% mean RU increment. We also verify our method on object recognition test. We use Caltech dataset as the label source modality dataset, and the Caltech dataset as a target modality dataset. The top figure shows the result of target to source mapping based on different number of stacked events. And the bottom figure shows the source to target mapping to different number of stacked events. Our method shows even better performance than the existing works for object classification. In conclusion, in this paper, we have proposed a novel framework called IfDistill for learning event-based end tasks. This framework consists of 2 modules. The first module is called bidirectional reconstruction module, and the second module is called distributed adaptation module. The experiment on semantic segmentation and object classification validates the proposed method. For more information about the experimental results, please refer to our project page. Thank you.